Hello dear viewers, today we will be discussing about the competitive based assignment solutions which I had already uploaded before, and I will be also providing the PDF version if you want it, or you can directly copy the questions from here. Here the first question goes like this: a body moves 6 meter north, 8 meter east and 10 meter vertically upwards. What is the resultant displacement from the initial position? Okay, so the solution goes something like this. Here we have the coordinate axis, or we can also choose to make the north, south, east, west diagram over here. And I suggest that for every these kind of questions you make a north, south, east, west diagram before. So this is north, south, this is east and this is west, right? Okay, now you are here. When you solve these kind of questions, make sure that we start from here. So from here we are moving 6 meter north, that means somewhere over here. This is 6 meter north, and from 6 meter north I am going 8 meter east, so the east would be in this direction. So that means I am walking 8 meter east and I am stopping over here in this direction. Again 10 meters vertically upwards. So 10 meter vertically upwards means I am supposed to go up something like this, and this I won't be able to draw because this becomes a 3-dimension thing. So that would be difficult for me to draw, but I can definitely make you understand. So here, first of all, suppose you start from point A, then you go to point B, then you reach at point C. So we know, as per Pythagoras Theorem, this is 6 square plus 8 square, that would be this square. So this AC square is equal to AB square plus BC square. This is 6 square, so 36. Plus this is 8 square, so it is 64, so this is 100. So AC would be equal to root of 100, that is equal to 10 meters, right? So this distance is 10 meter. Now again you are going vertically up by 10 meters. So from point C you are going 10 meter. So this is 10 meter, this is again 10 meter. So that means this would be again a triangle that is standing like this, and again we can apply. Let me find if I can. Okay, this can be actually understood with the help of a set square. So if I keep a set square like this, then like this, then this is the right angle triangle that I am talking about, right? So let me try to show you. This is, suppose this is 10 meter vertically upwards. So this is starting point, this is finishing point. So I'll put another marker pen like this, and finally this is the displacement, the length of this pen. So we have already found out the base, we already know about this, so we can easily find out this one. This is 10, this is 10, so this has to be 10 root 2. So again this is 10 meter, this is 10 meters, so final displacement is 10 root 2, because when we have two similar sides of the right angle triangle, the hypotenuse, that is the longest side, would be any one of the sides multiplied by root 2. So this is our answer, meters. So the correct answer is 10 root 2. A option is the correct answer. Second one, again a man goes 10 meter north, 20 meter east, then the displacement. So over here 10 meter like this, then 20 meter east, then what should be the solution? 10 over here, 20 over here, right? So again I'll be starting off with the same diagram. From this point, this is 10 meter, and then this is 20 meter. This is A, B, C. Then the final answer would be AC. So AC would be equal to under root of 100 plus 10 square is 100 and 20 square is 400. So my answer would be under root of 500 meters. That turns out to be approximately 22.5 meters, right? So our answer is 22.5 meters. A option is the correct answer. Moving on to question number 3. This was the toughest problem that most of the students had, and let us see how we do that, right? And question number 3 says that a person is moving 30 meters north. So again, by the same concept, we move on. So let's start by something like this. Suppose a person is starting from this point, right? This is the starting point, and this is north, east, south, west. So person starts from here and 30 meters somewhere over here. From here north 30 meters, so the person reaches over here, and from here he goes 20 meters like this. So suppose in east direction the 20 meter is somewhere over here. Going in this direction, suppose this is point A, this is point B, and finally he stops at point C. This is 20 meters. This entire length is 30 meter. Now from this point towards southwest, and southwest is this direction. So point C, from point C he is supposed to go like this. Now if you are not being given any angle, southwest means 45 degree. So from here at an angle of 45 degree, like this. Now I am very sure that this angle is 45 degree because this angle is 90 degree, and if this is 45 degree, so this has to be 45 degree, and it is because this becomes an isosceles triangle. So you have already this angle as 90 degree, so just match these two lengths to be same, and these two angles would automatically become 45 degree. Now finally the person stops over here, and how do I know that? Let us see this. So since this part will now become 20 meter because these are all isosceles triangle and both of them are having same length. We know that when this is 20, this is 20, this part will become 20 root 2 from here to here, and we know that entire long distance is 30 root 2. So from here to here it is 30 root 2, from here to here it is 20 root 2. So that means 30 root 2 minus 20 root 2 is 10 root 2, because root 2 will be common and 30 minus 20 is 10 root 2. So that means this segment is 10 root 2. Now this whole length is 30, this length is 20, so this length will be 10. Now as per Pythagoras theorem, if this is 10 and this is 10, then and only then this will become 10 root 2. So this distance is also 10. And finally we are reaching our answer. Look at this one. This is starting point. Then the person goes like this, finishing point over here. Starting point, finishing point, the distance between them is called the displacement. So the 10 meter is the displacement. From starting point to finishing point you are supposed to draw an arrow. This arrow will show the direction of the displacement. So finally our answer is 10 meters north. So 10 meters north is the correct answer, right? Okay, moving on to the next part. A wheel having a radius of 1 meter rolls forward half a revolution on the horizontal ground, and you are supposed to find out the magnitude of the displacement. So here what are you supposed to understand is, when a wheel rolls a complete rotation, suppose this is a wheel and this wheel, this is the point on the wheel, say for example point P. Now this wheel is moving forward also and it is turning also. So this wheel will roll down like this, and it is also going to go forward. And suppose the radius of the wheel is r. When this wheel takes a complete round and reaches over here, the point P again comes back at the same point, because after one complete revolution, point P reaches over there only, right? Now the distance travelled by the entire wheel, the distance travelled by the entire wheel would be equal to 2 pi r, that is equal to the circumference of the wheel. So when the wheel completes one full revolution, it travels a linear distance of 2 pi r, right? So if a wheel completes half rotation, this point will not be here. This wheel will be somewhere over here in between, and this point will be over here. So when wheel finishes half revolution, this point shifts over here, and this distance travelled would be equal to half of this one, so that is pi r. Half of 2 pi r is pi r, correct? So the same question was being asked over here, but it was displacement. So let's do this. This is the wheel, this is point P, starting point, and this wheel, after finishing half revolution, since it is also moving ahead, reaches over here, and point P comes over here. So the displacement is this, correct? Now this is the diameter, this distance we already know, so I am giving the name as A, B, actually this point is P, but anyhow B, and this point P reaches over here, but I am going to name this as C. This distance is diameter, and diameter is twice of r, we know that. It is the double of the radius, correct? And this becomes twice of r. This we have already discussed. This is pi r. And to my viewers, I am actually extremely sorry, because I was not solving question number 4, I am solving question number 5, right? So I will solve question number 4 afterwards. So this is the explanation to the 5th problem, right? So this is twice of r, this is pi r. So AB square plus AC square is equal to BC square. Now AB is 2r the whole square plus AC is pi r the whole square. This is BC square, right? And BC is what my displacement is. So this would be equal to 4r square plus pi square r square, that is equal to BC square. So BC is equal to under root of 4r square plus pi square r square. So BC is equal to, I'll take r square common from here, and pi square plus 4, and r will come out. So I'll have under root pi square plus 4 like this. And since the radius of the wheel is given 1, so BC is equal to pi square plus 4 whole under root, because this is 1 meter given. This is our answer. So C option is our correct answer, right? So maybe I can cancel this, and this is question number 5, right? Let's move on. Question number 4. An athlete completes one round of the circular track. So when an athlete starts a circular round, say for example from here, and he finishes one complete round, he will travel a distance equal to 2 pi r, the circumference, right? Okay, and radius is capital R in 40 seconds. So time taken is 40 seconds for one full round. Right? Now the time taken, they are telling us the athlete is running from here. He might be running several rounds, and the time taken to run those several rounds is 2 minutes and 20 seconds. 1 minute is 60 seconds, so 2 minutes is 120 seconds plus 20, so it is 140 seconds, right? I can split up 140 seconds to be 40 seconds plus 40 seconds plus 40 seconds plus 20 seconds. Now why did I do that? Because I know that one round takes 40 seconds. So this is one round, second round, third round, and this is 3.5 rounds. So if he starts from here, one round, second round, third round, third and half round. So this was the starting point, this is the finishing point, this is the displacement, so this is R, this is R. So your answer is 2R. Displacement is the shortest distance between 2 points, right? And question number 6. In question number 6, a train is passing from an observer, and this is the long train, and here is the person standing, right? He is on the platform, the train is on the track, right? And the complete train, the length of this train is L. So this complete train passes by the person. So the distance is always calculated from front to front or back to back. Now the front is over here, was over here. Now the front is over here. So the distance traveled by the train is itself equal to the length of the train, right? And the speed of the train is given as 30 meters per second. Speed is equal to 30 meters per second, and the time taken to pass completely is 3 seconds. So distance, which is equal to length, that is equal to speed multiplied by time, that is 30 meters per second into 3 seconds. Second getting cancelled. Your answer is 90 meter. Okay, so the correct answer is C option. Let's move on. Over here you are being given a situation in which a car is going through the town, then from here, then it passes by the tree and finally reaches the pylon and crosses it, right? And here the tank of the car is leaking, so the drops are being regularly dropped after 2.5 seconds. You can see that the drops, the distance between the drops are small. Here the distance between the drops are large, is very large compared to this situation. That means the speed of the car was slow over here, that's why the drops are nearer. The car is running with a very large speed, that's why the distance between the drops is larger, because the drops are being at an interval of 2.5 seconds. Now the car is driven at a steady speed of 10 meters per second through the town, so over here, right? And this means this is first dot, this is second dot, third dot, and so on. This is the start of the town, this is the end of the town. So the car was over here, it had dropped the first drop, then the car reaches over here, it has dropped the second drop. So the distance traveled by the car between these two drops is, say for example, D, and the speed is given 10 meters per second, right? And the drop and this drop and this drop, the timings between these two is given as 2.5 seconds. So that means the distance is equal to the speed multiplied by time. So that is 10 meters per second into 2.5 seconds. Second cancel. Answer is 25 meter. So the distance between these two drop is 25 meter, right? So the answer over here is 25 meter, correct? And Now the town is 500 meter across. So this town, the town is 500 meters across, so that it takes 50 seconds to travel through the town. So this town is 500 meters and we are supposed to prove that the time taken is 50 seconds. Now this is a very easy problem. In this, what happens is the total distance traveled by the car is 500 meters. This is the start of the town, this is the end of the town. Now the speed of the car is already given is 10 meter per second. So time is equal to distance upon speed. So answer is 50 seconds, right? Okay. B part. Now what are they asking us? They are asking us at a distance of 1000 meter outside the town. That means the town finishes over here. So the car is over here now. At a distance 1000 meter outside the town, I'm sorry. This is outside the town 1000 meters. So now the car is traveling over here, right? And it travels a distance of 1500 meters from tree to pylon. Now calculate the speed of car between the tree and the pylon over here, right? And they are telling that the drops are 75 meters apart. So now what is the situation? The car was over here and it has dropped a drop. Now the car reaches over here. It has dropped the second drop. And this distance they are giving as 75 meter. And we know that the gap between two drops is 2.5 seconds. So car traveled a distance of 75 meters and the car took the time as 2.5 seconds, right? Then the speed is equal to distance by time. So let us do the calculation. So this is 75 meters divided by 2.5 seconds. And what is our answer? 30. So our answer is 30 meter per second. Right? What has happened to the car between the end of the town and the tree? End of the town and the tree. So here you can see that the two oil drops are near, two drops are far away, still far away, more far away, and the distance between the two drops keeps on increasing. This only happens, the car was over here, the car was over here, now the car is here, car is over here. So the distance traveled by the car in the same interval of 2.5 seconds, 2.5 seconds and 2.5 seconds is becoming greater. That is only possible if the speed keeps on increasing. So when speed increases, it is said to be accelerated motion, and the accelerated motion is option A. Correct? Okay. Now each of these three parts of the journey takes 50 seconds. Calculate the average speed of the car. So the total distance, the average speed is calculated as the total distance upon total time. So the total distance traveled by the car upon total time is given as 500 plus 1000 plus 1500. So that is equal to 2500 plus 500, that is equal to 3000 meter upon the total time. Okay, we are supposed to find out what? Average speed. Yeah, total time is given as 50 seconds. So if we cancel, answer is 60 meter per second. This is the average speed. Correct? So total distance by total, oh I am sorry, I made a mistake. Here it is given each of the three parts takes 50 seconds. So I made a mistake, I am sorry. The total distance was 3000 meter, 50 seconds, 50 seconds, 50 seconds. So it is 150 seconds, right? Cancels 120. Answer is 20 meter per second. Pardon me, right? This is the correct answer. So the average speed is 20 meter per second. That means the car might have traveled with 20 over here, then less speed over here and again more square, but the average of all speed is 20 meter per second. Let's move on to the last problem. Ball is thrown vertically upwards and then caught again after 10 seconds. Which of these graphs is a correct answer to our question, that is the speed versus time graph. Now viewers, you are supposed to understand one thing. When we throw anything up, the earth tries to pull it down. So when the object goes up, the speed keeps on decreasing, and finally at the highest point the ball stops. And from there again the speed keeps on increasing, and when it reaches your hand the speed is maximum. When you are throwing, at that point the speed is maximum, then the speed decreases, and finally the ball stops, that is the maximum height point. And from there again it falls down, speed increases and becomes maximum when it reaches your hand. So when you throw, the speed is maximum, then the speed decreases, then it reaches the maximum height, over there it stops, again the speed keeps on increasing. So C option is the correct answer. So hopefully guys you have understood all the problems well. If you have any doubts, do comment in the comment section. Thank you for watching the video.